Okay, so let's look at a free response question without a calculator here. Two particles move along the x-axis, and we know the position of the particle. We have particle P, and we have particle Q. We know the position of P, we know the velocity of Q. So we want to know for part A, when is the particle moving to the left? So therefore, we need to figure out when the velocity of the particle is less than 0. So this is without a calculator, so we need to figure out that velocity. So x prime, right, x prime subscript p of t is going to be u prime over u for the derivative of the natural log. So that's going to be 2t minus 2 all over t squared minus 2t plus 10. All right, now t squared minus 2t plus 10, if we consider this one, right, if we remember b squared minus 4ac, our discriminant, so b squared will be 4 minus 4ac, so that's minus 4 times 1 times 10, so that is less than 0. So therefore, we know that we have no x-intercepts. So we know that t squared minus 2t plus 10 is greater than 0 for all t values. And 2 times t minus 1 is greater than 0 if t is greater than 1. So therefore, we are moving left if t is less than 1. Right? Now, we're given a specific interval, so we need to then say, so therefore it's going to be 0 less than or equal to t and less than 1. All right, moving to the left, if the velocity is negative, find that derivative. And once again, the derivative of the natural log of u is u prime over u. Something to memorize. Okay, from 0 to 8, inclusive, all the times when the two particles travel in the same direction. Okay, so we know that we have for particle P, right? For particle P, we know that we're moving to the left and we're moving to the right. Okay, well, for particle Q, here's what I have. Well, this looks to be factorable, I believe, but for sure we know it's a parabola that opens upwards, right? So I want to find those intercepts. Let's change the color to be able to see a little bit better. So this would be what we'd have. Two numbers that multiply to be 15 add to be negative 8. So t minus 3 and t minus 5. So that means that the left one is 3 and the right one is 5. So for particle Q, all right, so we know that that's 1. All right, and then we are at 3 and at 5 for particle Q. We don't really care about anything to the left of 0. But between 3 and 5, this particle is negative, and otherwise it is positive. So we're moving in the same direction. And let's see here. From 0 to 1, no. From 1 on, then that's going to tell us to be from 1 to 3. From 1 to 3, they're both moving to the right. And then as well from 5 to 8, and we end at 8 because 8 is our endpoint. Okay, so we'd say that we're moving from 5 to 8. Now here's where we need to be careful. 8 is included in the endpoint and it's not a 0. So we want to make sure that we include that 8 for our endpoint. So from 1 to 3, we don't need to include 1 or 3 because we are technically stopped for one of our particles at 1 or at 3. But at 8, both particles are moving to the right, so I need to include 8. Okay. Next, we want to find the acceleration of the particle at t equals 2 and then determine about the speed, right? So we know that if velocity, right? So if vq of 2 and v prime q of 2 are both positive. Just use a plus sign is fine. Both positive, or make it neater, both negative, then we know speed is increasing. All right, so we need to find the v prime. So v prime for q is going to be 2t minus 8, and that's 2 times t minus 4, and so I know v prime q of 2, v prime q of 2 is going to be clearly negative, and vq of 2, let's check out vq of 2. So the actual velocity at 2 is going to be negative times a negative, so the velocity at q is going to be positive, so therefore our speed is decreasing. Okay, so we're able to figure those out. And then lastly, find the position of the particle q the first time it changes directions. So we want the position at t equals 3, because t equals 3 is going to be the first time the velocity is 0. So the position at t equals 3. If we come through, we look, two particles move along, the position of particle q is x equals 5 when time is 0. So that's going to be 5, so x equals 5 when t is 0. So 5 plus the integral from 0 to 3 of the velocity q of t dt. So I need to find the integral. Man, a lot of work here. And yes, some of these problems, especially the later on problems, will have quite a bit of work. So we come in, we say, well, what's going to be our antiderivative? So this is going to be 5 plus antiderivative of t squared is going to be 1/3 t to the third power, minus antiderivative of 8t is going to be 8t squared over 2, and then plus 15t, and that's being evaluated from 0 to 3. Continuing with this, that's going to give me 5 plus, right, I'm going to have t to the third power over 3, so that's going to be 27 over 3, minus 4 times 9, plus 15 times 3, and then minus 0. So I've got all the right numbers in all the right places, and that's a good enough solution. That is the location of our particle. If I actually do that work, that's going to be 5 plus 27 over 3 is 9, minus 36 plus 45. So that's going to be 5 plus, looking through that, that's 18, and so 23. Position is 23, but satisfactory to give our answer there. Okay. So where are our points? For our points, did you say the plus 5? That's a point. Did you get the right antiderivative? That's a point. Did you have all the right numbers in all the right places so that you would end up with 23, but really you can just have all the right numbers in all the right places, and that's going to be 3 points total. Okay. For part B, we need to have the reasoning, and we need to show that the velocity is positive and the acceleration is negative. And we must have that acceleration found. It's okay to say positive, it's okay to say negative, but we must show that acceleration, and there's 2 points associated with this. Okay. For the next one, we have what is our acceleration for Q. We found the 2t minus 8 that we found earlier, or no, sorry, for the next one is velocity. So velocity of Q, doing a sign analysis, and we have to do a sign analysis on both, and do a sign analysis, and we get to our interval, and there are 2 points here. However, if you don't have this sign analysis, there are no points. So please make sure you include your sign analysis. Okay, and then the first one, moving to the left, we find the derivative correctly. So find the derivative correctly, and then moving to the left for our interval happened to be from 0 to 1, and that would be our solution. One we're moving to the left, and there will happen to be 2 points there. Okay, so a little bit longer problem. As you have questions, please ask. Be comfortable with your derivatives. Make sure that you're supporting your work. Do the setup first. Think of the reasonings first. Okay? Thank you very much for your time. Have a wonderful day.